Hi everyone, my name is Vignesh Ramesh and I'm a machine learning solutions engineer here at Snorkel. In today's demo, I'm going to show you how the powerful combination of Snorkel AI, AWS and Anthropic can actually come together to help you build state-of-the-art RAG applications. Make a start, I'm going to show you a basic RAG architecture. In a basic RAG off-the-shelf architecture, you start in the ingestion phase where you take your unstructured documents, chunk them, and convert them into vectors. During the inference stage, you take the user's query and do similarity search within your vector database and retrieve some chunks which are then put in the prompt, and the model does some kind of in-context learning to give you a final response. Now, the problem with this off-the-shelf, out-of-the-box architecture is it often fails. It fails for a number of different reasons, but perhaps the most important ones are domain specificity. Different enterprises work in very different domains, and consequently using open source embedding models don't always fit their use cases. This results in incorrect retrievals that are driven by low semantic differentiation between their documents with this open source embedding models. Inability to differentiate acronyms is another very commonly observed problem where the embedding model is unable to make the similarity of the differentiation between the acronym and the full abbreviation. We also tend to see problems due to the underlying LLM itself, positivity bias being something that we observe very commonly, where the LLM tends to answer yes to most questions when the answer is in fact no. So the yes-no bias or the positivity bias is very commonly observed. How we fix these systems totally depends on where it fails. It could be embedding fine-tuning that's actually required, or the model fine-tuning, or optimizing the ingestion pipeline. This is all down to how the system fails, and consequently, then you make the decision of how to actually fix it. Snorkel AI plays in these four areas. We can help you do data development to fine-tune your models, fine-tune your embedding models, or do prompt development, or even optimize your ingestion pipeline. Now, the demo today is going to be circled around Finance Bench, which is an open source data set of this format. You've got questions about the different companies and information that comes from 10K or annual reports. They've got 150 questions where human annotators have actually manually labeled the answers. They build an off-the-shelf RAG solution and test it against open source as well as proprietary models. And what they find is that most off-the-shelf RAG solutions tend not to work to production accuracy. Now, here is one example from the Finance Bench dataset on a RAG system that we built. Here's the question, here's the response, and these are the two different contexts. Most people tend to see only one thing, which is the response is incorrect, and they've got some kind of metric to measure that and say, my system is 50% accurate. But that doesn't tell us much. This particular system fails due to 7 different reasons, as you can see here. So how we optimize this system is totally dependent on where it actually fails. Now, here's a reference architecture that we typically tend to use to fix these systems. We start with the unstructured document still, but we enhance the content extraction pipeline using a chunk quality grading machine learning model, which is developed within the platform uniquely for your needs. What this quality grading model is capable of doing is going through these different chunks and labeling them as irrelevant or incomplete or acceptable, so we can do post-processing operations on these chunks. Once you've done basic chunking, it's important to enrich your content, and that could be in the form of metadata, which are tagged as additional variables, or it could be in the form of relationships between the different chunks and tables, or paragraphs and tables as a knowledge graph. You also can do dynamic chunking, which results in very high quality chunks. Once done, you will need to fine-tune an embedding model, and that's an exercise in data development. You need to curate these different prompts and different chunk pairs, which is done within the platform so you can fine-tune the embedding model. During inference stage, it is important to have a routing layer, because today you may have only one vector store, tomorrow you may have 5 different vector store, or tomorrow you have agentic systems that perform multiple different actions. If there's only one vector store, then it goes through the similar retrieval process, but perhaps you may want to consider using a re-ranker if your domain is quite broad. Again, another exercise in data development which can be done within the platform. Finally, we do prompt development, prompt engineering, do inference, and then evaluate these whole systems from within the platform. So that's an end-to-end reference architecture that we typically tend to take ideas from in order to improve these systems. With that said, let's jump into the demo. Your data can live in S3. So in this particular case, my data lives in S3 as a number of different PDF files of different companies and their annual reports. I build an off-the-shelf RAG solution outside the platform, and I import the data into it. What you're seeing here in Snorkel Flow is the instruction or the question, and then the response that this off-the-shelf solution is actually generated. And then you've got two context pairs. So this is one and this is two. One of the first things that I noticed when I built this system is that the retrieval often tends to get the document wrong. So for instance, in this case, the question is specific to AMD for the year FY 2022. The first retrieval is correct, but the second retrieval is from a completely different company. So this is from Intel. So obviously this is not a very useful context. Another example, so this question is from Amcor for the year 2023, but the first retrieval is from Amcor for the year 2022. So what I noticed was that the retrieval system gets the name of the company wrong in some cases when doing retrieval, or the financial year wrong in other cases. Bear in mind, I've typed out the name of the file itself here. So when you download it from SEC's website, this is not how it's going to look like. So what I do is I create these three custom label schemas for my annotators, for my experts to come and give me some metrics, some annotations to do. They help me annotate this in three different dimensions. The first is overall acceptance of the response itself. The second one and the third one specifically around retrieval. The second one focused on company. The third one focused on whether the financial year referred to is correct or not. So they have a workflow within the platform where they come in and accept or reject these responses based on these three different criteria. What that helps me do is evaluate the system overall. So what I'm seeing here now is the results of that SME evaluation, SME annotation. This tells me that my system is 14% accurate, which is not very good. And this is being driven by two primary reasons. The first one is that the company referred to is correct only about 73.5% of the times, and the financial year referred to is correct only about 36.7% of the times. So there's a massive opportunity for me to fix these two and consequently achieve a higher accuracy in the overall percentage. Now, how do I do that? Fairly simple. What I do is I import all the different PDF files, the 10K reports into the system, into the platform. And once again, I request my SMEs to annotate a handful of data points, right? So in this case, this is an example of a financial year. So I request my SMEs to annotate it as FY, and this is an example of a company. So they come and annotate it. Once they do that, and we don't need very many of their annotations, we can use a programmatic data development approach in order to build a model which is able to predict the name of the company as well as the financial year very reliably. How do we do that? Three-step process. Step one, we build labeling functions. Step two, we train and develop the model. Step three is we analyze the performance of the model, and if you're happy with it, then we export it. To train this model, we need lots and lots of label data. And how do we get that label data? Through labeling functions. To give you an example of a labeling function, what I do is I create a keyword-based labeling function, and I'm specifically looking for the different spans. These are the different spans. And if the span contains the words period ended, then I'm going to label that automatically as a financial year. I know this because I've seen so many of these documents, and I know that the financial year is typically hidden in the same span as where this period ended. What my labeling function does is it looks at every single span, labels all the data automatically, and comes back and tells me how precise this particular labeling function is. This is done using the validation set. The SMEs have already annotated some of this data. So it goes and checks against that ground truth data and tells me how precise it actually is. Another way to actually label some of this data is using prompts. So Snorkel's integration with SageMaker allows us to query some of our models that are actually running in their endpoints. So in this case, I might say, what is the name of the company reference in this filing? And this automatically queries all of the text within this document into our model running in SageMaker, and it comes back and provides me with different labels. We can also use embedding models, so the different spans are clustered in using a spacey embedding model in this particular case, and I look for very homogeneous clusters. So, for instance, this particular cluster has 27 documents. 14 of them have been labeled as financial year by my SMEs. So there's a good chance that the rest of the documents are also financial year, so I can save that as a cluster. Those are labeling functions, and we go through the process of creating these different labeling functions. And what this does is it generates labels very quickly for our dataset. So in this case, 9 labeling functions have generated 974 different labels. Once we're through with that, we can train a model. A number of different training architectures are already available. It could be a simple gradient boost, or it could be more advanced transformers architecture. You can train these models within the platform. And once done, you can analyze how this model is actually performing. This is a clarity matrix, and it gives me guides on how to actually iterate through this process. So in this case, my model does really, really well. So I'm happy with this model, and I go away, take it, and deploy it in a SageMaker endpoint. Ultimately, what I try to do is actually extract the two important variables, which are the names of the company and the financial year, and that's now available. So what I do is I incorporate them within my different chunks. So in addition to the other metadata attributes, I've got these two attributes, and consequently, my retriever works better. Now, let's go back and evaluate the system once again. So how does this system compare to the previous system? So I've got an out-of-the-box 4.0, and I've got a metadata enriched system. And you can see the jump in performance by a simple trick, right? So 14% to 47% accuracy. And this is driven by the improvement in company reference to and the financial year reference to going up significantly higher. Now, information extraction is still quite low in terms of the accuracy. I'm still only performing at 57% accuracy. And we can improve this because the information extraction questions they depend on the embedding model. So we can fine tune the embedding model, and hopefully that will improve the performance even more on this particular category. How do we do that? Once again, an exercise in data development. What I do is I bring in all the PDF files that are in my S3 bucket as URLs. So you can generate these URLs on AWS. Once that's available, it goes through a sequence of pre-processing steps where the PDF files are downloaded, they are cleaned, the text gets extracted, and all the other metadata attributes are added. But finally, I have these individual paragraph spans which are extracted from our PDF files. From here on, I can do one or two things. I can generate synthetic data. So this is a code-based operator. I use my SageMaker runtime using my own specified domain endpoint. And I ask the model to simply write a question for this paragraph. Now, this is the easiest way to generate data. There's only one problem with this approach, which is that users may not necessarily ask questions in this exact same format. They may have other questions. And that's where we need to programmatically label some question and chunk pairs using Snorkel's data development approach, right? So I have selected, say, a list of about 50 different questions, and these questions are listed here. I programmatically tag the different paragraphs to these specific questions. Very similar approach to before. Once done, we can launch a fine-tuning job, because what happens at the end of it is we merge these two different data sources. One, where we programmatically curate question and answer pairs, and two, where we synthetically generate this data. And once that's available, we simply launch a fine-tuning job and we run inferencing on SageMaker. There is an excellent tutorial on how to fine-tune embedding models on SageMaker available on GitHub. I highly recommend you to take a look at it. Now, how will we perform after this? So we're going to compare the performance of that model with the embedding fine-tuned model, or we can even take a look at the chart. And what the chart tells me is that the performance has improved even more. These are the three different systems that we've looked at, and the embedding fine-tuned model performs the best among them all. Once again, let's compare. So in this case, I'm comparing the out-of-the-box versus the embedding. Sorry, the embedding fine-tuned, and I see performance has gone up overall at 63.3%. Now, if you have a keen eye, you will probably notice that performance is starting to tank for some of these categories. So this one, which is on logical reasoning, has not really improved. This is because reasoning is not really the job of the embedding model or the retriever. Reasoning is actually the job of the LLM itself. Now, what do we do with that? So one way to do that is to use other models. Consider your context to be golden, and run inference on different kinds of models. What we have realized within Snorkel AI is that Claude 3.5 performs extremely well on reasoning. So that's why we've developed an integrated Bedrock inferences for Claude 3.5. And what you can do is simply change the different prompts. You've got the user prompt as well as the system prompt, holding your question and your context as fixed, and allow the model to actually do inferencing. From here on, you can also sort of see how SMEs have provided feedback in the previous iteration. So in the previous iteration with 4.0, my SME has said that the numerical reasoning was actually accurate. But for this question, for the previous iteration, my SMEs told me that this is actually inaccurate. So I'm very keen to know what they think about this particular generation from Claude 3.5. So all I have to do is just create a new batch of annotations, allow my SMEs to give me feedback once again. So that's that brings us to the end of the demo. I want to leave you with this particular future state architecture. Fine-tuning RAG systems is actually a fairly involved process, and it needs to be done for your own specific domain, for your own specific data, and what you use and how you fix these different systems is totally dependent on where it fails and what data development techniques will actually help you fix these systems. Thank you.